Now let's talk about instantaneous velocity. Recall that average velocity is equal to the displacement over the time interval. To find the velocity at an instant of time, what you do is allow the time interval to get really small. Okay, so for example, let's say you're in a car and you want to figure out the velocity at an instant of time. What you actually do is just think of a very small time interval, which of course would correspond to a very small displacement. That would give you an average velocity over a very brief period of time, and for all practical purposes, that would be called the velocity at an instant. Can you ever have an instantaneous velocity? Of course. Just make the time interval smaller and smaller and smaller and smaller. In the limit, when the time interval is 0, you would have an instantaneous velocity. So just imagine a time interval approaching 0, and then you have velocity at an instant. Now, all this that I said can actually be mathematically represented by the following equation, which is not a real useful equation in this course as far as solving problems. But its use is just to explain to you what we mean by instantaneous velocity. Here it is. If it's an instantaneous velocity, you write it like that. You take the average sign off of the symbol here, and I'm going to shift this over. Delta x, the displacement over the time interval, and in front of it, I'm going to say the limit as delta t approaches 0.